Welcome back my dear friends and dear students. A very good morning, good afternoon and good evening to all of you wherever you are in this part of this world, whether in India or abroad. And as you know, this is the DADM, which is Data Analysis and Decision Making 2 course or lecture series under the NPTEL MOOC lecture. And this total course, total number of weeks is 12, which is 30 hours, 30 hours being expanded into 60 lectures, because each lecture is for half an hour, and each week we have 5 lectures. After each week we have assignments. So, as you can see, we are in the 33rd lecture, which is basically the 7th week going on. 2 weeks have already 2 classes have already been completed for the 7th week, and my good name is Raghunandan Sengupta from the IME department, IIT Kanpur. So, if you remember, we were discussing Topsis method, and the concept of outranking was coming up in the discussion, that how would you outrank decision 1 with respect to decision 2 or alternative 1 with respect to alternative 2. So, in case that is there, you will basically consider the criteria also to make the decision. And when you are doing that, you will basically have the concept that there is an ideal solution, and you will try to find out the distance, positive and negative sense, that will come later on. The concept of distance based on the ideal solution, how close or how far it is. So, if it is positive ideal solution which you want, so obviously you will try to be as close as possible to the positive ideal solution. Hence, you will give positive benefit to your decision. In that case, if I and j being basically the nomenclature trying to basically mark the alternatives 1 to m, and if I and j are being compared alternatives and for any criteria, and if it is positive, so obviously we will give the distance is as close as possible to the positive ideal solution. So, it will be a positive benefit. If it is closer to the negative ideal solution, it will be negative. Similarly, if it is further away from the positive ideal solution, it would basically lose its importance, that alternative with respect to the other which you are trying to compare. And if it is further away from the negative ideal solution, obviously in that case the negativity would start decreasing going towards positivity. So, we are, as I said, we would not consider too close to a positive solution means too far from the negative solution, or too close to the negative solution, it means that it is too far from the positive solution. We would not consider that, in the sense that asymmetricity of the decision would be maintained. So, I was discussing the pseudocode based on which we will solve a problem slowly. So, I in the last class, which is in the 32nd class, I did start, I hardly spent about 1 minute 2 minutes for this algorithm, but and then I said that I will stop it here because the half an hour was almost over. So, I said I again take up this algorithm, or based on which the procedure based on which you will work and try to solve the problem. Now, the algorithms can be changed, in the sense general flow process would be the same, but the methodology or at each and every step the decision, or say for example, the utility function, normalization, all these concepts may change. So, that would depend on the decision maker, as I told that this utility function is important. So, considering those are changing, but we will follow the general structure of the algorithm accordingly. So, as I said, you will basically have X matrix, which is m cross n, m is the number of alternatives, n is the number of decision criteria, and this X which matrix would basically be, each cell would give you the corresponding values which accrues to that alternative based on the criterias. So, cell say for example, A11 would basically be the corresponding value which is coming out from criteria 1 to alternative 1. Similarly, cell A31 would be the corresponding value which is accruing or being given by criteria 1 to alternative 3 and so on and so forth. Apart from that, and these and A's would be the corresponding alternatives, and small c's would basically be the or capital C, they are not the concept of criteria. So, c's would basically my mistake, c's would definitely be the capital C would definitely be the criteria, because the C what I am referring here is not the C what we have referred in the electro process, remember that. And we will have basically a matrix W, where W1 1, then W2 2, W2 3 3, W4 4, so on and so forth, which is the principal diagonal with the values which will be assigned to of the weights based on the fact that what weightages or what importance you will give to the criteria in making the decision. We should also ensure, I am still in the line 1, we should also ensure that the sum of the weights should be 1, and we will basically find out the normalization based on the utility function. Now, remember one thing, I am mentioning it time and again. So, please bear with me, the utility function which we will be utilizing would be constant for that set of procedure which you are doing, point 1. We will also try to maintain that if the person is going to take decisions stage by stage, obviously the utility function should not change. Point number 4 is that when you are trying to normalize, use the concept of normalizing along the row or along the column, such that you maintain the parity from step 1 to step 2, step 2 to step 3, so on and so forth. So, once you find out, say for example, the normalized matrix, you will basically multiply the normalized matrix with the weights to get the so called normalized weighted values, which are the percentage wise so called utility, normalized utility, which you will be getting for alternative 1 with respect to criteria 1 or alternative 3 with respect to criteria 4, so on and so forth. But because the size of the matrix would not change. What I am saying, that when you are trying to find out y is equal to basically x into w, here x is a normalized vector, the size of x is m cross n, size of w is n cross n. So, m cross n multiplied by n cross n gives you the final matrix of y as m cross n, m as in Mangalore, n as in Nagpur, which means that I have basically for each of the columns I have the criterias, and corresponding to each of the rows I have the basically the alternatives. So, each cells would give you the overall normalized weighted values which accrues from each criteria to each of these alternatives. Once you find that, you will basically find out the so called positive distance function and negative distance function, and find out for what sets of values of j's. Here you will basically have PIS, that means it will be an element in that set, and for what set of values of j's, it will be in the set of NIS, which is negative ideal solution. So, PIS is the positive ideal solution and NIS is the negative ideal solution. So, once you have this, what you will try to do, you will try to basically find out the set of the decisions. So, they would be basically for PIS, you will try to find out the positive one, and also so called how further it is from the positive one. So, one is set of closer values, one is the set of further values. Similarly, when you do it with respect to the NIS, you will find out the how close it is for the negative solution and how far it is from the negative solution. Now, when you have that, you will basically find out the ranking based on this ideal solutions distance, both for the case for the PIS and the NIS. And once you do that, you will basically find out the so called the ranking system based on both the 4 columns 4 columns are nothing to do with the rows or nothing to do with the columns what we have discussed about the alternatives and the criteria, remember that. These are the basically the so called distance functions, normalized distance function which I am getting with comparison to the PIS positive negative, that means close and far from PIS. Similarly, the third and fourth column would be the corresponding distance function based on how close and far it is from the NIS. So, once you do that you will basically be able to find out the ranking for each and every alternatives by considering the combination of the criteria. Now, remember here I am again repeating, when you are going to take the 4 columns, 2 with respect to the PIS and 2 with respect to NIS, the actual fact is that the first and the second column will be utilized to find out the so called positive benefit, and the third and fourth column would be utilized to find out the negative benefit. It is something to do with the concordant set and the discordant set. So, with this I will basically start and discussing this. Once this very simple theoretical concept with a very simple matrix, and then go into trying to make a decision that how you choose a house based on the different criteria and the alternatives which are given. So, let me go into the simple first set of concepts of the distance concept. Now, you remember that whenever we are trying to find out the distance, so distance can be of different varieties. So, distance can be Euclidean distance. So, in the Cartesian coordinate you have, say for example, 2 dimensional one, you have 2 values x1 y1 and x2 y2. So, if you want to find out the distance between those 2 points, consider them as A and B. So, where A has a coordinate system as x1 y1 and B has a coordinate system as x2 y2. What you do is that you basically find out the difference between x's, square them up, find out the difference between the y's, square them up, add them up and find out the square root. So, you will basically have the Euclidean distance, and as per the concept you have if you want to find out the difference between the points are given as x1 to xn and y1 to yn. You basically find out the difference, square them up, add them up, find out the square root. Now, there are different norms of the distance functions. Some of them in statistics concept there are different type of norms. This is the Mahalanobis distance, Bhattacharya distance. Then in concept of information theory they have the Hamming distance. In general concept of mathematics you have basically the L1 norm, L infinity norm, L2 norm, LP norm. So, all these things are there, they can be utilized, but I am only going to consider the Cartesian coordinate in a very simple way to solve our problem. And obviously, these norms would have some concept of the distance which would be basically coming out from the utility function. We will consider the utility function to be, because there are only 4 utility functions which we are considering. So, we will consider the utility function to be quadratic, hence the returns to be normally distributed. Based on this we will proceed. So, trying to basically minimize this distance, if you remember, gives us the information. You will try to basically find out the difference in of the squares, and then try to basically find out the average value of that and try to minimize that, which leads us to the fact that you are trying to basically minimize the variance, which is characteristics which I have been talking time and again. So, the L1 norm or Manhattan distance. So, in Manhattan, New York, all the roads are perpendicular to each other. So, based on that they are just rectangle setup. So, that is why it is known as the Manhattan norm. So, L1 norm is basically this distance where you find out the mod of the difference of these values, which is basically here I have not, just let me change it, I have not done it. So, the Manhattan norm would be given by the sum of the mod of these values of the errors, no, the differences, and then you will basically find out the values. 1 minute. So, in the Mahalanobis distance you basically find out there are 2 random vectors. You basically find out the multiplication of those differences and find out them multiplied by the covariances. So, what you are trying to do is in some way trying to find out the variance and trying to minimize that and try to find out the minimum one for the Mahalanobis one. Similarly, for the Hamming distance, the values would be basically the position is the number of position at which the corresponding values are different. You will find out the differences, find out whether it is 10 or 15 in number, you report that number, that will give you what is the overall n means the number of such differences which are there, which will give you how far or how close those two vector set of points are. Then for the L infinity norm, you basically find out the max of these differences between x and y. So, you have x and y's the difference you find out, and then you find out the maximum of this distance for the L infinity norm. And for the LP norm, you basically find out the differences in the mod value, try to find out to the pth power and then add them up and then find out the square, or say for example, the power 1 to the power p, based on which you will try to basically find out the LP norm distance. Now, here as I mentioned, we will only consider the L2 norm, which is the Euclidean one, based on which we will do the calculation. So, now first the part what we will consider is a very simple theoretical example, and then I will go into the as somewhat practical example, where your main set of information is being given, where you want to find out how you want to purchase a house depending on different criteria. So, assume the value of x, which is the matrix of the decision values. So, these are given by, and this is, remember, this is the m cross n matrix. These are cells values are given by x 11. I am only reading the topmost row, x 11 to x 1n. So, that means corresponding to the first alternative, what are the so called values you accrue for that alternative, based on the fact that x 11 would be for the first the criteria, x 12 would be for the second criteria. Similarly, the last one x 1n would be for the last criteria. Similarly, if I go to the last row, so x m1 would basically the value which is accruing from the criteria 1 to the mth alternative. Similarly, x mn would basically be the value which is accruing from the nth criteria to the mth alternative. So, once you have that so called decision values, they are given, remember that would be given. So, you need to find out the normalized values. So, we are using the very simple concept of the normalization concept, which is x I j divided by the square root of the sum of the squares of these values for each and every cell. Now, the word what I said last is basically each and every cell would be either considering the row wise or the column wise. So, say for example, I want to find out the normalized value for x 11. So, I can either do the normalization along the first column or along the first row. So, if it is along the first column, the actual values in the denominator, I am not talking about the square root, I am not talking about the summation, I am only talking about the squares inside. So, it will make you easy. So, basically you find out the squares, add them and find out the square root. So, the values which will basically add them are corresponding to the fact, if you are going through the column wise, it will be x 11 whole square, then you will basically have x 21 whole square. So, 21 which I am mentioning is in the subscript, and the square values is in the superscript on the top. Then the third value will be x 31 square, till the last value it will be x m 1 square. You add them up, square root, and if you find out, then each values along the first column would be divided by the fact which I mentioned. Now, if you are trying to find out the normalization concept, okay, another thing which I should mention. So, once you have normalized, so if you go to the second column, you will basically use each and every cell values which are there in the second column, you will basically square each of them, add them up, square root, and that would be the denominator in each and every values, which these would be utilized to divide each and every values in the second column. Similarly, for the third column, the value which you will utilize to divide each and every cell for the third column would be the corresponding square of each and every value for the third column, which would basically be x13 whole square, x23 whole square, x33 whole square till the last one, which will be xmn whole square, m3 whole square. Now, if you are doing the normalization along the rows, so let us consider the first row, the values which will be coming in a denominator would be likewise like this. It will be x11 whole square, then plus it will be x12 whole square, then plus x13 whole square till the last value, which is x1 whole square. Now, if I go corresponding use this concept, go to the last row, the corresponding value which will be coming in a denominator, again I am not going to mention the square root value, I am not going to mention the sum, I am only mentioning the values which will be summed up. These are like this: xm1 whole square plus xm2 whole square dot dot till xmn whole square. So, once you have that, you will basically have so called the normalized set, which I will mention as R. So, these are the values which I have done. So, their normalization can be done either row wise or column wise. I am not going to details what is done here, but you will surely understand. So, assume the values which are given for the X matrix, the priority so called values which are here are the first, I am only read the first row, which is basically 10, 25, 25, 30, 15. Similarly, the last row is 20, 30, 30, 35, 5. Now, remember one thing here, the number of this alternatives is 4 in number, which is the first row, second row, third row, fourth row, and the number of criteria which are there, which is the first column, second column, third column, fourth column, fifth column. That means 4 number of alternatives and 5 number of criteria. Now, consider the value of 40. So, what would 40 mean? That means it would mean for the third alternative, the value being accrued by the third criteria would be 40. Similarly, if I consider 5 here, so it means that for the fourth alternative, the value being accrued by the last criteria is 5. So, once you have that, you normalize, again use either the row wise or the column wise. Now, here what I have used is, I have given these values, but I have used 2 different calculations in order to make you understand. So, in this case what you can do, if you find out the square root, so obviously the values would be 10 divided by the sum, which square, which is 10 square 100, 5 square 25, 15 square 225, for 20 square 400. So, this value would be utilized for each and every value calculation in the first column. Similarly, so if I go to the second column, the corresponding square values are 25 square 625, 15 square 225, 25 square 625, 30 square 900. So, these values are given. So, here I have considered the square root in the corresponding third, fourth, fifth. I am not considering the square root, but I am just giving an example. So, they are again square values of each and every corresponding cell values in the third column. Similarly, fourth, so we basically find out the square root of so I should also mark it with blue color, so you will understand. So, blue goes blue, green goes green, red goes red, yellow goes yellow. So, the blue one means I am squaring 30, which is 900, 40 which is 1600, 45 which is 2025, 35 which is 1225. Similarly, come to the last column, (15 square 10 square, 10 square, 5 square. So, these are the values. So, once you have this, the normalized values, considering the square root 1, I have these. So, if you change it, it will be giving you different values. So, if you want it, let me show you the differences. So, it will be easy. So, I will use the Excel sheet. So, I will use this table, these values. So, let me write them 10. I will call it myself and I wrote it down. So, there is no mistake. I am calling for the first column 10, 5, 15, 20, 10, 5, 15, 20, which is 10, 5, 15, 25, 15, 25, 30, 25, 15, 25, 30. I go to the, so I should also mention that what I mentioned. So, it will be A1, A2. So, it will be easy for you to understand. So, these are the alternatives and so obviously criterias. I will use C1, C2, not that C concept which is coming out when you do the concordance discordance set. I will continue using C here. So, there were 5 criteria. So, it is done. So, let me come to the third 25, 35, 40, 30, 25, 35, 40, 30, 25, 35, 40, 30, 30, 30, 45, 35, 30, 30, 30, 40, 45, 35, 30, 40, 45, 35, 15, 10, 10, 5, 15, 10, 10, 5. Now, I will calculate different values. So, I will write the weights later on. So, let me write them. I would, okay, let me, if you are insisting. So, I will do first the simple normalization, which is sum. So, this should be dollared in order that it does not move values. So, I have, so now see. So, this value is basically first cell divided by the sum of all the cells. This is the second cell divided by the sum of the cells. This is the third cell divided by the sum of the cells. This is the fourth cell divided by the sum of the cells. So, I will take another few extra minutes for this class. It will be exceeding 30 because I want to finish 30 minutes because I want to finish this table. So, this would be divided by sum so it will be dollar here, dollar here, dollar here, dollar here. So, done. So, this will be 25 divided by sum so I put a dollar. So, I fixed it, copy, done, come to the fourth column, put a dollar here, dollar here, dollar here. So, this is done and last column sum of this. So, put a dollar here, so copy. So, last, now to wrap it up this class. So, obviously, you have normalized along the columns. So, let us find out. Obviously, this will be true, but I want to show it to you. So, this is 1, 1, 1. So, if you could have done it along the rows, that would have been the same. So, with this I will end this 33rd lecture, and in the 34th and the 35th, which will be the last two lectures for the 7th week, I will try to wrap up the example of buying the house in the using the Topsis method. Have a good day, and thank you very much for your attention.